Now this illustration deals with the grounded conductor in accordance with NEC 250.32 B as in boy 1, and we're using the exception 1 here. Now, in this illustration, we have an existing panel board in the building to the right. Same situation, we have a 225 amp main with 4 conductors feeding the panel board for illustration's sake. Now, we have to determine how we size this grounded conductor based upon it being used as a bonding means, as a path for an effective fault current situation or condition, and as a neutral. So we can do this by using the information in the step 1 through 3 in the boxed in information. But before we perform the calculation and size everything, I'd like to go over the notes first. Note 1, feeders are run to supply other loads. Note 2, other utilities supplied from other locations. And then number 3, the grounding electrode conductor is sized from table 250.66 as required in 250.32E. Now notice in the call out information there's a number 4 neutral with a feeder. It's rigid metal conduit, elbow there with PVC between it, no parallel paths. The neutral load is 50 amp continuous type load. All terminals are 75 degrees C, and we're using a THWN conductor, and the phase conductors from building to the left to the building to the right are 4 THWN. Now the grounded neutral conductor that you see in the boxed in information in the facility to the right, the grounded neutral conductor used as neutral and equipment ground in accordance with the exception to 250.32B1. Now with this information, we will now look at our steps 1 through 3 and the solution. Now, step 1, we're calculating the grounded neutral conductor. We're looking at 220.61A, 225.8B as in boy, and 310.15E3. If it's a Y system, for example, you have to see if over 50% of the current on the neutral is nonlinear or harmonic related type current, and if that's the case, it's the neutral's current carrying. Now step 2, we're looking at 250.32B1, exception 2, and 310.16. Now the 50 amp calculated load requires number 8. The 100% of the maximum current, which is 50 amps on L1, L2, or L3, would be 50 amps. And we're using 100% here because we know the code allows that as an exception. Do you have to do it? No, you do not have to use the exception. You could take 50 and 125% as the designer or electrician or contractor if that's what you want. But I go to 100%. The exception allows that. So it'd be just number 8. Now number 3, I have to select the equipment ground in step 3. So a 225 amp main from table 250.122 requires a number 4 conductor for 225 amp overcurrent device. So which is the largest between step 2 and step 3? The number 4. So that's what would have to be selected to route over there to serve as a bonding means, a path for fault current, and a neutral load too. Now, let's look at this another way. Say that we add 150 amps, continuous calculated load, already calculated, 150 amps. Then step 1, we'd add 150 times 100%, which would be 150. Step 2 then, 150 amp would require 1 aught, so now you would need a 1 aught run over there to serve as a neutral, 220.61, and serve as an equipment ground, 250.122, and then it serves as the bonding means. Now that's what this figure 16-56 is pointing out. You always use the larger of step 1 or step 2 in accordance with 250.32b1, exception 1.